All right, Calculus, welcome to the hopefully last video of your Trig review prereq series here. Hopefully in the next few days you'll figure out how we are coming back, and every day we are together in person, folks. We are going to learn a lot, fast and furious. So it is very important that you have these notes down for when we meet in probably about 5 weeks. All right, this is the first video using the new tripod system here, so bear with me. If I do have to do e-learning throughout the year, I'm going to want a little better setup so I can actually show doing stuff, which I haven't here. This is just kind of like the old videos. But anyway, let's see how this goes. So 120-degree angle, all right. Where's that out? Where's that at? So like, what would be cosine 120? What would be sine 120? How would you do that without a calculator and no knowledge of the unit circle, or you forgot? Oh, you're like, oh, is it root 3 over 2? Is it 1/2? I don't know. So you go 90 degrees. Then you go another 30. You make your right triangle. If that is 30, that's 60. Remember, makes a right angle. 60's here. 30 would be there as 90's there. Opposite 30 is 1. Opposite 60 is root 3. Opposite 90 is 2. This is a negative 1 because, again, you're in the second quadrant. X is negative. So cosine of 60 is a negative 1 over 2. Or, sorry, cosine of 60, but also cosine of 120 is negative 1 over 2. Sine of 120 is root 3 over 2. All right, so that's how you can make reference angles, and all that leads to the unit circle. Examples, last page here. You will see several of these. Look up here. Use the range for theta to determine the indicated function values. Given that sine of theta is 7 over 10, and theta is in the second quadrant, find cosine of theta and tangent of theta. How do I know it's in the second quadrant? Pi over 2 is 90 degrees. Pi is 180 degrees. Got to be in the second quadrant. So I draw a right triangle. Again, the right angle is always formed at the x-axis. Sine of theta is 7 over 10, so opposite adjacent Pythagorean theorem time, which I've done here, gives you root 51. But remember, x is negative in the second quadrant. That is a negative root 51. You got to be careful there. So cosine of theta is a negative root 51 over 10. Tangent of theta is opposite 7 over adjacent negative root 51. I'm going to multiply top and bottom by negative root 51. Negative times the negative is a positive at the bottom. A root times itself eliminates the root. Last question I have here for this first little video series. There might be more, and if there is more, definitely jot it down because I want us getting off to a good start. I did teach you in Honors Algebra 2 or Algebra 2, so I'm feeling a little bit more, feel better about what you're going to bring in. I know when I taught you certain things, and I've been in communication with Mr. Jones, so I also know what you had. So, folks, we're gonna get at it to start the year. Anyway, cosine of theta is 2/3, and theta is in the fourth quadrant. So find sine theta and tangent theta. That is the fourth quadrant. First off, it's sitting at 2 pi, which is back at the start. Okay, so cosine of theta is adjacent over hypotenuse. Again, the right angle is made with the x-axis. It is a positive 2 because you're going the positive right direction for x. Pythagorean theorem, which I've shown you here, gives you a negative root 5 because you're going south. So sine of theta is a negative root 5 over 3, and tangent of theta is a negative root 5 over 2. All right. This isn't bad, this tripod. I can show work pretty easily while also filming, and this is going to work well. All right, folks. This is Yakamath Videos for a short time, signing out.